It's June already, and in the last 6 months of producing this podcast, we've actually had a lot of fun. What used to be a 2 to 3 month process for producing a yearly statistics report in past years is now an agile monthly analysis. We are now tracking application security statistics alongside the fast evolving threat landscape. And in doing so, I feel that we've actually been able to add a lot of context to what the raw stats we produce say. A couple of cool examples here. When we were tracking the SolarWinds outbreak, we were also tracking the window of exposure data for the manufacturing sector. And recently, when the Colonial Pipeline issue came to light, we started tracking the window of exposure data increase in the utilities sector. The net conclusion in both these examples was that no matter what the prevailing narrative about security is, the ground reality is that security is a priority only after an incident has occurred. And I'll go a step further and say that the half-life of this behavior of prioritizing security is actually very short, meaning that there's a rapid drop in the attention given to security after a few days or weeks of the incident. Now, in creating this podcast, I've also had an opportunity to exercise some creative freedom. I've had deeper conversations with industry experts like Vishwas from McAfee, Alan from Now Secure, Dina from Momentum, Cindy from Insights, and Casey from Buckcrowd. And in fact, each one of them has provided actionable takeaways that have added to the way I think about cybersecurity.
Welcome to White Hat Security's AppSec Stats Flash, the monthly podcast on the state of application security. Hosted by Setu Kulkarni with analysis from White Hat's in-house security expert, Zach Jones.
Now, we did realize in the process that the podcast needed to be split in the middle, so we have 2 episodes a month. The first one where I deep dive with the experts, and the second one where I unpack the raw application security statistics with my good friend Zach Jones. We have released this month's expert podcast with Matt McClarty from MuleSoft, and we've touched upon what he calls the 3 ways of the API. And we've extended those 3 ways to now include security as a key feature. Now, if you're remotely associated with APIs and API projects at work, I'd highly recommend reading Matt and his co-author Tiffany's write-up in the Harvard Business Review. We'll post a link to that in the show notes. And also then take a listen to my conversation with Matt. With that out of the way, let's turn our focus to the state of application security. And first up is window of exposure. Now, if you're a first-time listener to this podcast, the window of exposure, in my mind, is a bellwether metric. It basically is a proxy for breach exposure. Let's say you have a web application running in production for some time now. The window of exposure metric tells you about the duration or the window of exposure for which your application has at least one exploitable serious vulnerability. Now, last month, we had observed that utilities as a sector had the highest window of exposure on average for the applications within that sector. Now, what that means is applications in the utilities sector have at least one serious exploitable vulnerability open throughout the year. Now, the same data point is seen in this month's stats as well. Utilities continues to be the number one sector as far as window of exposure is concerned, not in a good way, but in a bad way. Over 67% of the applications in the utilities sector have at least one exploitable vulnerability open throughout the year. Now, as we started looking at this data more deeply, one of the things that we realized was that some sectors like finance and insurance exhibit a key difference that is worth digging into. When you look at finance and insurance, we find that while 43% of the applications have one exploitable vulnerability throughout the year, we also find that almost 30% of the applications actually do not have vulnerabilities that are open throughout the year. These 30% of the applications actually exhibit a very different characteristic. What we find is that for these applications, serious vulnerabilities actually get fixed within 1 month, under 30 days. So let me bring Zach in here. Zach, what does this trend tell us? Can you unpack that for us a little bit here?
So I think what we see is a divergence in sort of active projects. Projects that are under active development have frequent releases, and sort of legacy applications or applications that are in maintenance long term are being operated but don't have active development. And so in those industries and across the industries, it sort of makes sense that if you have a planned release on a regular basis, your opportunity to remediate a vulnerability in 30 days or less, let's say, is pretty high. If you have releases every 2 weeks or even every month, you have that planned opportunity to go in, make a code change, and deploy it to production. But in your legacy application that you may be releasing an update to once a quarter or less, you either wait for that release to deploy some change that fixes a vulnerability, or you have to go through the process of doing an out of band release, a patch release. And many organizations maintaining those legacy applications may not have processes in place for exactly how to do that. So they begin scanning, they discover vulnerabilities, and then based upon the risk of those vulnerabilities, have to make an assessment of when they can actually remediate them.
That seems to be a pretty untenable situation, right? You've got hundreds of applications which are potentially legacy applications that have no active development on them, but they still have hundreds of thousands of users that are accessing this application and are being serviced. So where does that leave the security operations team, right? They've got applications that they're responsible for, they're testing and they're finding vulnerabilities, but they don't have anybody to fall back on to go and fix or remediate those vulnerabilities. So how does a team deal with that?
So like we've talked about in a couple of other areas, I think the most important thing is having that plan in place, right? You don't see a lot of benefit from doing a security assessment if that's the end of the plan. And so these security and operations teams have to look at their investment profile of these legacy applications and know what their envelope is for engineering work and know what other resources they can bring to bear in order to conduct mitigation of issues that might be found, especially critical risk issues.
So, Zach, let's pull on that strand a little bit more. At least you and I know from our experience with the work that we do with our product and engineering teams, is that at the start of the year, we make a conscious effort to outline what's the level of investment in net new greenfield projects and projects that have been running in steady state. Now, is there an opportunity here for the security leadership team, the chief information security officer or director of information security, to basically look at that investment profile and really embark on what I'd call a two-speed AppSec approach, right? You think about the AppSec program, but within the AppSec program, there are two swim lanes. A swim lane for greenfield projects where there's a different strategy for application security. And then there is another swim lane for steady state, may I say, legacy type projects where there's not as much engineering investment and create a different application security strategy. What do you think about that?
I think it makes good sense. I mean, I know from experience in working with our customers on the code scanning side of the house in SaaS that that's the reality on the ground for many organizations. They really have these two different classifications of assets. And if you take that bucket of legacy applications and you try to apply the same strategy of application security to them that you're doing to your greenfield projects, you'll probably find you're going to be walking up a pretty steep hill because all of the effort to do things like development lifecycle integrations and all that stuff requires engineering investment as well as the security team investment. And so if you don't have that planned as part of the profile of that asset, then you're likely not going to get very far. So to think about that investment and to look at what are your alternative approaches, right? We can talk about a simple example like looking at a web application firewall approach, where you may be deploying a web application firewall across all of your assets as a matter of compliance policy. But knowing that you're going to have vulnerabilities discovered in those legacy applications that out of the box, the web application firewall may not be preventing, you're going to need to go back to your security operations teams that can go into those application firewalls and do custom configurations to remediate those vulnerabilities without having to pull on a development resource. So I think looking at that investment profile of those assets and then aligning the strategy for how you're going to respond to things like vulnerability reports could lead to a lot less frustration for those teams that are responsible for managing the risk of those applications.
Yeah, that makes sense. So maybe a good takeaway for the listeners here, for our audience today, is the concept of two-speed IT is not new, right? There is kind of a well-documented movement called two-speed IT. And I think the key takeaway today that we are proposing is, let's start looking at the application security program itself. And when we double click on it, there are necessarily two approaches that need to be a part of your application security program, right? The first swim lane, where you're addressing the needs of legacy applications that are running in steady state. And then the needs of greenfield projects where there's a lot more software development investment, and aligning the application security program and strategy to product development investment strategies kind of critical to make application security work. Now, let's kind of wrap that and move on to the next stat that is something that we've been tracking for quite a long time. This is vulnerability likelihood by class. And what we've found over the long time that we've been tracking this, the top 5 remains more or less constant. We see the same vulnerabilities pop up over and over and over again. And these are basically information leakage, insufficient session expiration, insufficient transport layer protection, cross-site scripting, and content spoofing. Now, Zach, let's try and double click on each one of these vulnerability classes for the audience today. And what we should do really is, instead of addressing the technicalities of each one of these vulnerability classes, why don't you give us an example of how each one of these vulnerability classes manifest themselves in production, right? And let's start with information leakage.
So for information leakage, we're primarily looking at reconnaissance gathering on the part of the attacker, right? The application providing internal details, and that enables the attacker to find new attack surface, right? And for all of these top 5, I definitely recommend that folks go back and look at our previous episodes, because I believe, with the exception of cross-site scripting and content spoofing, that we've had a lengthy discussion about the technical details of the top 3 at least. So don't forget to go back and check out those former episodes that do those as well.
So on information leakage, I take it there are at least 2 kinds of information, right? There's information about the end user, and then there's also information about the application itself, the infrastructure on which it is running. So both of those are contained in information leakage, correct?
Yeah, absolutely. And what we found is that the information about the user, which is probably what most people think about, is actually less common than the leakage about the application itself.
Cool. Let's kind of move on to the next one, which is insufficient session expiration. Why don't you expand on that for us, please?
So insufficient session expiration, to kind of put it in a simple term, would be, how long can you stay logged into the site through a period of inactivity? Or when you click log out, do you actually get logged out, right? And the way an attacker can exploit this is that if they are able to compromise your session token, right, your identifier, then that window for which their basically hijack of your account remains valid is dependent upon how long that session will stay valid. And so that's where you hear about sort of a hijacking of users through sort of various social engineering things, as well as technical exploits.
So if I were browsing on the internet and I had 2 tabs open, one tab where I'm logged in and I'm doing some work, I don't know, maybe with my bank, or I'm looking at some personal information, and then there's another tab open, is that creating an opening for insufficient session expiration to be exploited?
Yeah, absolutely. Right. Anytime you have long-lived ability to stay authenticated to the site without that site timing you out, because of the way the internet sort of handles communication in your browser, it opens up an opportunity, given certain other vulnerabilities exist, for an attacker to conduct actions on your behalf in applications that you're logged in another tab or even in another window in certain browsers.
So really then the bottom line is there are kind of two parties who can take responsibility to avoid getting breached through insufficient session expiration, right? The development team or the software team behind the application, they put in the right controls that prevents this long session kind of situation. But at the same time, as end users, isn't there a behavior change we can make to make sure that if we're working on a bank account on a tab, before we leave the tab, we just exit out, close it, log it out?
Yeah, and you can even go one step further. One of the things that White Hat has internally talked about and externally talked about is, have a play browser where you do all that fun stuff, social media and reading news articles, and have a completely separate browser for when you're doing serious work, right? When you're doing transactions online, things of that nature. And the browser that you utilize for banking and other things of that nature, don't leave it open, right? Open it up, conduct your business, log out of the site, and close the browser down. That really lowers the amount of potential exploitation that can occur through various attacks.
With those golden nuggets, let's kind of move on to the next vulnerability class. It's insufficient transport layer protection. Double click on that for us, Zach.
So this is about the communication between typically your browser and the site that you're operating with and whether or not it's encrypted, right? And the major exploitation scenario here, the simple one that we can talk about is, being on the public Wi-Fi somewhere at a coffee shop, right? If there is an insufficient transport layer protection vulnerability in the site that you're browsing, then that means that there is the chance for eavesdropping, right? If you're on Wi-Fi, that information can be pulled out of the air with a radio antenna, right? And if it's not encrypted, then potentially that information that you're sending or receiving from that site can be read by anyone. And by having proper transport layer protection, we prevent that from being the case. And that's where sites should not rely on, the network to do that protection. They should have that end-to-end encryption to provide protection to their users.
And for end users, maybe one thing to start looking for is HTTPS, right? When you access the web application, are you accessing it over the secure HTTP protocol or not? Is that an easy check that end users can do?
Absolutely. The browser vendors have increasingly raised the standards on this and have made it easier and easier to identify when you are connected securely to a site versus when you're not, right? That's the little lock icon in the left side of your browser bar in most mainstream browsers. They've also, in some cases, just completely started disallowing HTTP connections entirely, or at least warning you that there's an unencrypted connection. And then the other thing is, if you do see a warning, take heed, right? Don't click through those warnings. Oftentimes users will just click through to get to what they're after. But, if your browser warned you, there's a reason why it's warning.
Exactly, right? Instant gratification is what makes you click before you think, as I said. Now, when we talk about insufficient session expiration and insufficient transport layer protection, the end users can actually do something, right? There are telltale signs that there is a vulnerability. For information leakage that we spoke about at the top of the list, are there any telltale signs that end users can keep an eye out for?
Well, most of it, especially on the site side, is going to take a little bit more of a technical eye, right? But certainly, if you're browsing a website and you see errors, right, and those errors have a lot of detail to them, even if you don't understand it, at least me personally, that gives me sort of a pause about what the trustworthiness level of the site that I'm interacting with is. And then the other dimension would be related to, so many sites, so many apps ask for so much information constantly, right? And as a consumer, we have to start taking a little bit more initiative to say, do I really want to provide that information? Do you really need that to provide this service to me? And in some cases, deciding not to use the service if they're demanding more personal information than we're comfortable to provide.
Let's switch gears to the last two on the list for us today. Cross-site scripting. Why don't you expand on that for us, Zach?
Yeah, absolutely. And cross-site scripting and content spoofing are kind of a two for one. They're kind of two flavors of the same underlying issue technically. For an end user, what cross-site scripting typically would manifest as is these are phishing links, right? These are things where someone is trying to get you to click on a link or to visit a site. Maybe they take out an ad that says win a free iPad, right? And what they're doing when you click on that link or they're visiting a malicious site is they're taking advantage of a vulnerability in a target website. So, a social media site or a banking site that has one of these vulnerabilities will enable that attacker through you clicking that link to take actions on your behalf if you're logged into that site. And so that's really most of the manifestation of this attack to an end user would be that type of phishing activity or win an iPad ads, that you see pop up.
So one of the things that pops in my head, Zach, is when I'm on the browser, and I suspect this is true for most of our listeners as well, technical or non-technical. When I'm on a browser, I'm almost always multitasking, right? I'm not focused on one thing. I'm looking at 3, 4 different tabs. And that lack of focus usually prevents us from really looking at how the application is interacting with us. And oftentimes we're just looking for the green button to click so that we can get on to the stuff that we wanted to get done. Maybe there is a behavioral change that we need to make as end users of software applications over the internet. Be very mindful of the application that you've opened when you're interacting with it. Make sure you're focused on the task that you're trying to complete, because the moment you lose focus and the application presents you with a big green button, you're more likely than not to click it.
Yeah, absolutely. Driving our own personal behaviors is one of the long-standing challenges of information security, right? People are often the weakest link in the chain, and it also speaks to our demand, right, for security. If we are not behaviorally acting as if we value security in the way that we use applications on the internet, then there's less incentive for the people responsible for delivering them to us to invest as many dollars in security.
Right. Maybe what we'll do is, as a complement to this particular podcast episode, we'll produce a short list of end user behaviors that could potentially help us as a society avoid the exploits of the top 5 vulnerability classes that we're tracking. And at the same time, we're also going to do a future episode with Matthias, the co-founder of Secure Code Warrior, who hopefully will talk to us about how do we take this information about the top 5 vulnerability classes and convert it into a plan that we can present to the developers, the DevOps teams, the QA teams, potentially the product management teams, to create a more robust, multi-pronged strategy to secure our applications better. Zach, that was a great, healthy conversation. I really feel that we addressed the issue of the top 5 vuln classes, both from a technical aspect, but also what can end users of the software do to prevent breach likelihood for themselves, right? So with that said, let's move on to the last segment of today's podcast. Again, an important one. We've been focused on OWASP top 10 for the last 5 months, right? OWASP top 10 to us is an unordered list, but an important list, because when folks are introduced to security, application security, the first thing almost always is the OWASP top 10. And the way the OWASP top 10 is laid out, it's rich content, but it's unordered, right? It starts from A1 to A10. And what we've been doing over the last 5 months is looking at our statistics data and trying to map our stats back onto the OWASP top 10 and creating an ordered list of the OWASP top 10. So far, we've covered A6, A3, A5, and A2, which are 4 out of the top 5 from our perspective. And one of the broad takeaways for us has been that, at least for A6, A3, A5, and A2, it is actually a lot to do with configuration management, making sure that the configuration of the software that is running in production is actually tested and robust and does not present inadvertent vulnerabilities when the software is running in production. So let me bring you in, Zach, again. Give us a couple of examples about some of these configuration changes that we need to make sure our software is running securely in production?
So when we go back to, we talked about information leakage, which is basically the A3 sensitive data exposure, right? We've talked in the previous episode about application debugging being enabled and the fact that this is most often not something that you have to go into the code to change. Typically, there's a configuration file or an environmental flag that changes the logging level of the application. And that can also change the errors that are displayed to the end user as well, right? So that's one example where testing in production to validate that these modes are properly enabled to not expose sensitive data is almost always a configuration change to remediate that vulnerability. And then another one that we talked about under broken access control, which at first glance you wouldn't think would have a lot of opportunities for configuration. Turns out when we look at the quantity of vulnerabilities and place them in various buckets, what we found is the huge majority of broken access control issues that we were seeing were related to cross-origin resource sharing issues. And again, that is something that many times can be applied at an infrastructural configuration level, where something like a reverse proxy can be configured to always include the appropriate security headers without developers needing to go into the individual pieces of functionality and code them up to include the proper security headers.
Makes total sense, right? When you were talking about configuration, this is not a configuration example, but I was reminded of Scott Tiger. If you remember the early days of the database, I shouldn't say the early days of the database, but in the early 2000s, when you used the Oracle database, the default username was Scott and the password was Tiger. And I've seen so many applications that actually went into production with that default configuration for the username and password. Do you think that still occurs today? Maybe not in the case of databases. Maybe we've gotten better as a community about changing the default username and password on databases. But for other components in the software stack, I suspect that occurs today still.
Yeah, I think most folks would be surprised the volume of detections that we have related to things being on their default, whether that's default usernames and passwords or other default configurations of applications. And one of the ways that I talk about this when I do sort of high-level application security talks is I talk about the ABCs of application security, right? And the C in the ABCs of application security is configuration, right? It's one of the three legs of things that you have to look at any application in order to try to produce more secure software.
Makes total sense. So now that we've kind of done a quick recap of A6, A3, A5, A2, let's focus our attention today on A1, which is injection. I know injection is kind of an implementation type vulnerability, right? In the sense that most injection vulnerabilities arise because of an implementation error. And most of the injection vulnerabilities can't actually be fixed by a minor configuration change, right? They're not configuration dependent so much. Is that kind of a fair, broad statement that injections are more implementation vulnerabilities and can't be actually fixed with configuration changes?
Yeah, that's correct. But the one exception that I would bring up is that most of the injection flaws that we see discussed in breaches and in the news are injection flaws in third-party pieces of software that other applications incorporate into their tech stack. And in that case, you don't have to go fix that code, right? All you have to do is update the version of that vulnerable piece of software that you're using. So I think that would be the one exception, but it's a pretty big one because that's a pretty big practice that people have to be paying attention to in order to help their software be more secure.
Got it. So with that said, now let's double click into injection. When we look at injection data, obviously there are multiple vulnerabilities that make up injection data, but by far the most common injection vulnerability today is SQL injection. And it's kind of sad because we've known about best practices around database interaction and development for a long time. There are best practices that are taught in school, for example, on how to access a database securely from your code. So help us understand a little bit more about two things, right? One, what the SQL injection actually is. And I know there's a very famous example, right? And I actually had a t-shirt that said or 1 equal to 1. So talk to us a little bit about or 1 equal to 1 and what SQL injections are. And then some of the ways that developers can actually take care of avoiding SQL injection in the first place.
So SQL injection vulnerabilities arise because applications want to query databases in a dynamic way, right? They don't just want to run the same query. They want to run a query that queries for user A and then a query that queries for user B, or whatever dimension the dynamic nature of the query is. And what can happen is that when we want to do that dynamic query, we take in some piece of user input that contextualizes what we should be querying. And the easiest way to write that query, if you're trying to do a naive implementation of some application, is to concatenate, to write your static part of your query as a string and then add on your dynamic part of the query either at the end or somewhere in the middle. And if that's done, then what that allows is for the user input part of the query to be altered by whatever I send to the application. And that's where the or 1 equals 1 comes in, right? The or is a SQL control statement. And if it's not protected from where you would anticipate, I would say user ID 1, in my select statement, I might say user ID equals 1 or 1 equals 1, which evaluates to true. So we return back all users or the first user, depending on the database that we're using. So that's the core problem.
So what you're saying really is you're writing a SQL query and you're, let's say, naively doing a select star from, and in addition to the condition where user ID equal to 1, you also concatenate or 1 equal to 1 at the end. Only one of those two conditions has to evaluate to true. Either user ID has to be equal to 1 or 1 has to equal to 1, which is always true. So the result set that you get is now everything in that table. And that result set may eventually get populated into an object that might get displayed on screen.
Absolutely. It becomes more complicated with complicated queries, but at the end of the day, there's more than a handful of full of tools that once you identify, you have some control over the query that the application is running behind the scenes. Those tools can, in an automated fashion, begin to figure out the logic of what the injection needs to be in order to accomplish running whatever underlying query you want to, in the end, in the worst case, right, just dump the contents of the entire database.
Got it. So let's kind of step back now. We did a deep dive into the most popular, or I shouldn't say most popular, most common vulnerability in that broad injection classification. What are some of the other common injections that we see?
So the second most common one is HTTP response splitting. And then sort of followed behind that, we would have application code execution and various forms of XML injection. So things like injecting into SOAP web services and things like that. There's quite a big list. We produced, I think, a top 6 or 7 in the data that we pulled. But that's an important point about the A1 injection category is it's really large. They all have a commonality in the technical aspect of what injection is and the way that it works. But the ways that it can manifest across all the different technologies and the different edges of those technology being the database or the HTTP layer or the application code layer or on, causes this class of A1 injection to splinter out into quite a large number of vulnerability classes. And then the other point that I would mention about A1 injection is it's A1, right? It's the first one on the list. But when we look at the data in terms of the actual likelihood, the absolute likelihood of various forms of A1 or even in aggregate compared to the ones we've talked about in previous episodes, it's less common, right? But the reason it's such a big deal is that these are very critical risk vulnerabilities when you do have one, right? Oftentimes they don't require other user interaction. Oftentimes they can really lead to complete compromise of the target. And so they still get that A1 headline, even though for the case of SQL injection, in the last year, the likelihood of any given site having a SQL injection vulnerability is around 1%, right? That's still bad news that 1 out of 100 websites is probably vulnerable to a complete compromise through SQL injection, but it's certainly less prevalent than some of the other vulnerability classes that we've talked about.
Yeah, but the silver lining here, though, is it's a completely fixable vulnerability in code, which means if there's adequate training, number one, for developers, it's going to go a long way, provided developers can embrace that training and take the training. The other piece that I wonder is, especially for SQL injection, there needs to be a conversation about secure design patterns, right? As an architect, you should always be thinking about secure software and secure architecture. So whenever you're making a database query, maybe making sure that you're always delegating the query to a microservice that is hardened to make secure queries to the database and reject ill-formed or vulnerable queries, so to say. That might be a design pattern that we should start thinking about as we're architecting the application.
Yeah, we've seen a lot of this trend, both from the architectural perspective of where you have an architect and a security architect developing these interfaces for developers to use in a way that's hardened. That's a very important concept for implementation vulnerabilities in general, right? But then there's also a trend at the sort of software component level where many things like ORM software that allows you to query your database have been developed in ways to drastically reduce the opportunity for these implementation flaws to exist. Oftentimes, there's still some narrow misuse cases in those frameworks that still can result in a vulnerability. And I think that's definitely the case where the architect and the security architect can come in and say, okay, we choose this library because it's hardened in the vast majority of cases. But how can we then go in and provide interfaces to eliminate the rest of those cases, especially where we know that the use case of our software is going to hit those potential places to make mistakes? And then the other upside you get from design like that is it makes detection of those vulnerabilities when they do come up a lot easier, right? Because you don't have to do bespoke scanning if the organization says, here's the way that we compose a database query that is known to be safe. You're not allowed to compose a query in any other way, right? It's much easier to detect that violation in software than to try to simulate the data flow of the software and say, oh yeah, that's a SQL injection vulnerability. It's much faster.
One of the things that, as you were talking about kind of that approach, one of the things that came to mind was that prescription is very aligned to the way software development is done. But when you want to create a prescription on the other side of the coin, which is the security team, maybe there are two things that we can leave the security teams with, right? Number one, ask the question, do you have database best practices in development? And the answer should almost always be yes. And if the answer is no, you can pretty much go back to the development team and say, look, you are potentially vulnerable to SQL injection at runtime. The second, more directed question that the security team could pose in their checklist is, are you using something like a Hibernate, right? Something that abstracts developers' code from the database and is an intermediary that allows for all the checks to happen more or less in a framework type of way. What do you think about those two recommendations or prescriptions if they are embraced by the security team, if they were able to ask those two questions in their security checklist? I think that'd go a long way in preventing or at least minimizing SQL injection.
So I would even take it one step further, and I'll abstract this a little bit away from SQL injection and just talk about how security teams can function in general. I've observed a pattern with organizations that have very successful application security programs in their thinking. And that thinking being transitioning to becoming toolsmiths and enablers of developers allows for a really sneaky way to have success, which is if, say, DevSecOps staff, right, people that are empowered as developers and security teams together can build ways of building applications that are first easy, but also secure, you really heavily incentivize the rank and file development teams to be more secure, right? Here's the easy button to do this, and it just happens to be secure, right? Then the chance that the team is going to go do it the hard way and also the more vulnerable way becomes much reduced. So that pattern, I think, is very powerful and is something that I've seen these organizations really buy into and really materially affect outcomes across the vulnerability landscape in that way.
Totally. Look, Zach, I think we touched upon a lot of topics today, right? Starting with window of exposure, the top 5 vulnerability classes, and OWASP top 10. A lot of key takeaways here. Let me try and summarize today's conversation, and obviously we'll create some material to go alongside this podcast so people can read it as well. The first big takeaway is thinking about two-speed AppSec. When you look at your application inventory, make sure you're able to easily tag applications that are steady state, potentially legacy, that do not have a ton of engineering or development investment in them. And you need to take a different strategy to secure those applications. And then when you look at the applications that are left over, which are potentially the Greenfield applications, new applications that are going to be in the business for the next 5, 7, 10 years, you've got to take a slightly different approach to application security, where you can start thinking about engaging multiple tool sets, creating security checkpoints within your software development lifecycle, and taking a more multi-pronged type of approach to implementing security in those new Greenfield applications. So that's kind of one big key takeaway for us, right? Think about two-speed AppSec as a strategy. And the second big takeaway for me, especially in the conversation we had around the most common vulnerability classes, was yes, there is a role that developers have to play. Yes, there is a role that security operations has to play. Right, but there is also a role that the end users have to play. And I think we did a pretty rich deep dive into how do these top 5 vulnerabilities actually manifest, and what does it mean for users? And at the end of the day, how can users actually take a little bit more control of their own destiny, the security part of their destiny, and exhibit good behavior on their parts and prevent getting breached? Now, with that said, let's wrap up today's conversation. Before I do that, quick thank you to Herman and Lauren for making this easy as always. Stay safe, everyone.
Thank you for listening to White Hat Security's AppSec Stats Flash podcast. To learn more, download the report or visit us on the web at www.whitehatsec.com.